Okay, do you guys remember what a composite function is? Who remembers what the composite function is? Does anyone remember what a composite function is? What is a function? It's a function within a function, right? So it's when you have, for example, f at g at x. So you have two functions and you're subbing one function into the other. Okay? You guys have seen this as f with a little o, right? Open circle, g, f of g, or g of f. You guys have seen it like that. Okay? And you would have done that in advanced functions. Okay? So composite function. So we're going to now talk about how to take the derivative of composite functions. And we're going to be using, again, the chain rule. Okay? So we're going to do it by example. I think it's easier than by looking at the definition. So I showed you guys Leibniz notation here. And I think it's easier to understand how to take the derivative of the composite function when you look at Leibniz notation. So here I have dy over dx. What that means is you're taking the derivative of your function y with respect to x. So x is the independent variable. Y is the dependent variable. dy dx. dy dx is equal to the derivative of u. So why is there a u here now? Because we are introducing another function. This other function is also going to have a common variable in it. Okay? So I'm taking dy dx equals dy over du. So the derivative of y, but now with respect to u. So now your independent variable is u. And you're going to multiply the derivative of u with respect to x. You're going to notice that the du's cancel, and that's why this is the derivative. Okay? You see how they're equal? Left-hand side equals right-hand side. It equals dy dx. Again, you'll understand it when you see it through example. So here I have y equals, or f of x equals 3x squared, and g of x equals root x, h of x equals f of g. So what does that mean? F of g. What am I doing here? What's f of g here? So what will h of x equal? F of g. Yes, Tom. Beautiful. So you're going to take your f of x and you're going to sub g of x in for x. Right? So wherever there's an x in f of x, you're going to sub your g. So it's 3 root x squared. Here is my g of x right here. Good. And when you simplify this, it just equals 3x. Good. So that's the function f of g. Now I want to take the derivative of that. So what's the derivative of this? Easy. What's the derivative of 3x? 3. It's just 3, right? Right? The exponent of 1 comes down, 3 times 1 is 1, x to the 0 is 1, it's just 3. Good. Okay, now I'm going to do it separately. I want to find the derivative of x, So the derivative of 3x squared. What is the derivative? Come on, guys.
6x.
Yeah, thank you. Come on, you guys should know this, right? Now, g prime of x. I want to take the derivative of the square root of x. What should I do to it first? Negative. Sorry, not negative. Make it a
Fraction.
yeah, x to the 1/2, right? We're going to make it. We're going to write it with an exponent. So we know that that equals x to the 1/2, and we're going to take the derivative of that. So what is the derivative of x to the 1/2? The 1/2 comes down. Beautiful. There's the derivative. Okay. Now, using that chain rule.
Wait, isn't it negative 3 over 2?
Okay, so let's try. So it was like this. So you had x to the 1/2, and you have to subtract 1, which is 2 over 2. So this
Oh,
is,
right. That's true.
yeah. Right. Okay, so now, by using our definition of the chain rule, which we saw on the last slide, and I rewrote right here, we know that the derivative is equal to the derivative at g of x times the derivative of g of x. So let's see if the two derivatives equal. Let's see if it works. Okay, so f prime of g at x. Well, what is g at x? What is our actual function g at x? Root x. Thank you, Tom. And now we're going to multiply by g prime of x. Well, what did we find was g prime of x? It's right here, 1 over 2x to the negative 1/2. So now we're going to sub in our derivatives. F prime, I found out to be 6x. Well, now I want f prime at root x. So just sub in root x. 1/2. 6 root x multiplied by my g prime of x, which we just saw was 1 over 2 root x. I just cleaned it up. Right? I made the exponent positive, changed it to a root, the 2 is already in the denominator. Multiply these together, and what do you get? Three. Do the two derivatives equal? So we said h prime of x equals 3 using the chain rule. And doing it separately, yes, or doing it, excuse me, using just our regular derivatives, we saw that h prime of x is 3. The two are equal. Okay, so this is showing you how this equals this derivative. Okay? Are there any questions so far?
Miss,
Yeah.
do we have to get rid of the negative sign on the exponent when we solve?
Not when you're simplifying, yes, at the end. When you are simplifying, you do.
Oh, thank you.
Okay? Yeah, when you're simplifying, you do. Okay. Yeah. I'm going to show you. We're going to do it through example, and you're going to see. We're going to do it both ways. Okay? So you'll see. All right. So here we have two functions. I have y equals 3u squared plus 7u minus 4. That is my function where the dependent variable is y, but the independent variable is u. There is my extra variable. You see that? So when I take the derivative of this, when I find y prime of my first function, I am finding dy du. Okay? So when I take the derivative of this first function, I'm going to find dy du. Okay? When I find the derivative here, what would my derivative be?
du dx.
Beautiful. Du dx. The dependent variable is u, the independent variable is x. Beautiful. Du dx. Perfect. All right, so let's find dy du. So when I find dy du, what is the derivative? You're going to do it the exact same way as x. My independent variable is now u instead of x.
6u
Yeah.
plus 7.
Perfect. Thank you. That's Steven? Was that Steven? I just like knowing one.
No, that was me.
Oh, Radine? That was me. Doesn't help. Radine, right?
Yeah.
Yay. Okay, thank you so much. And now we're going to find du dx. So now I go to where my u is my dependent variable, and I take the derivative. So what's the derivative of 2x cubed minus x? What's the derivative? Simple derivative, yes. Good. And we learned that in order for me to get dy dx, I am going to multiply the two together, right? That's how it equals. So look, dy du multiplied by u dx will equal dy dx. And so now I'm going to multiply these two functions together. And so I have 6u plus 7 multiplied by 6x squared minus 1. What's the problem with this answer? Why can't I leave it like this? What is the problem here? What is the problem here? Yeah. Yeah, I have two variables. Beautiful. Which variable do I want? I want x. So how can I get rid of u? I want to get rid of this u that's being multiplied by 6. How do I get rid of that u, Tom? Amazing. Thank you. We know that u equals 2x cubed minus x. It said so in the question, right? That's the function. We know that. We're going to sub that in. So we're going to sub in. So now I have 6 times my u. And then this can stay, it's got an x in it, right? That's my independent variable, we're good. And all we need to do now is clean it up. Do I have to expand this whole thing? What do you guys think? Go back to what we said about simplification. Do I have to expand everything here?
No.
No, good. I want it factored, right? So we want it as 2 factors. But I do have to clean up my first bracket. So we're just going to clean up the first bracket and leave it as a simplified factor, okay? So this is going to be 12x cubed minus 6x plus 7, 6x squared minus 1, and this is our slope function. This is our derivative. Yes. When we're simplifying, we want to see our factors. The reason you want to see your factors is because if it can be simplified further, if it can be canceled, we need to see your factors. Also, when you're graphing, we need to find our zeros, and we've learned from functions that when it's factored, you can more easily find your zeros, right? Yeah. Yeah, no problem. And now it says, what is the slope of the tangent when x equals -1? So all I have to do is take that slope function and sub in x equals 9. Or excuse me, -1. Okay, remember guys, slope function allows us to find the slope at any point. And now you clean this up, you get -12 plus 6 plus 7. One times 1. Okay, which means that the slope when x is equal to -1 is 5. Any questions? Okay, let's do another example. So do you see, Tom, how this is a little bit cleaner than finding all of the derivatives separately? This is a nice, easy, cleaner way to do it without having to use your actual composite, FIGLS. Okay? But essentially, you're doing the exact same thing, right? Okay, here we go. Here are my 2 functions, and I want to find dy dx. So what do I have to do first? Yes. Oh, yeah. It might have been something that I added. Does anyone else have it on the PDF? Okay.
You can write it.
Is that okay?
Yeah.
But thank you for telling me.
Just wondering if that was like, I mind to.
No, okay. You know what? We're constantly changing our lessons, so it could be that I did the PDF before I. But mind you, or maybe I just cut it off. Like, do you have a homework?
Yes.
Yeah, so I added it in. Okay, so I'll add it in the PDF as well. Okay, so what am I going to do first? Amazing. So first, find the derivative of your first y with respect to u. And we know that that's from Leibniz notation, dy du. The derivative of y with respect to u. Okay, derivative of y with respect to u. Who wants to do it for me? Nathan, help me out here. Right here. Take the derivative of this for me. Yep. Beautiful. There's my dy du. Sorry, I don't know why I'm doing this separately here. Hold on, give me a sec. These two things remind you of it. So we want to find dy dx. We know it's equal to dy du multiplied by du dx. And as you just told me, Nathan, it's 6u squared plus 6u. And this is going to get multiplied now by du dx. Well, du dx, I'm going to change its form before I take the derivative. It's x plus x to the 1/2. So who wants to take the derivative for me? John, you want to do it? Derivative of this.
All right. Good morning.
Yeah, no, that's okay. That's okay. So derivative of x will just be, it's 1x, this one. Good. And then over here,
But, 1 over 3 and negative 1 over 3.
good. Okay, I'm just going to write it as x to the 1 with 1/2, and then we'll simplify it. It's absolutely right. That's what it is. Okay? And so here, I have 6u squared plus 6u. Can I leave in the u? What do I need to do now? When I look at this, I notice I've got too many variables. So what can I sub in for u?
X plus square root x.
Thank you. So here I have 6 times my u, and it's squared. 6 times u. And now here I'm going to simplify it the way that Sean did. All right. Let's clean it up. So, what does this become? What do you guys think? What should I do here? Remember how we like our simplified form. Okay, that's all I need to say. Remember how we like our simplified form. Good, amazing. You're going to factor here. What you should notice is in that first bracket, we have a common factor. What's the common factor? What's that common factor in my first bracket?
X plus square root x.
You got it. 6 times x plus the square root of x. So what does that leave me with in here? Well, I factored out the 6. I factored out 1 of the x plus root x. So I've got 1 left there. And I took this whole thing out. Now, when you're fully simplifying, you should not leave this 1 plus 1 over 2 root x. The rule is when you're fully simplifying, you should have 1 denominator. So let's simplify this fully. If I want 1 denominator, what should I start by doing here? Finding a common denominator. Yes, we want to find the common denominator here. So here, I'm going to multiply 1 by 2 root x plus 1. Okay? Remember that this is multiplication. So because this is multiplication, I'm just running out of room. I'm making sure. Okay. So this is still not fully simplified. Why? What should I do in the very last step? You know, we're not going to worry too much about rationalizing. No, I know, it's silly, right? Because when do you rationalize, when don't you? We're not going to worry about rationalizing. In fact, we leave a lot of our exponents as fractions. You're going to see that. You're going to see us leaving exponents as fractions, okay? So we're not going to worry about that. The problem here is that 2 root x in the denominator. I want to bring that over my entire function. You're going to have 3 factors in the numerator. Because it's multiplication, right? I can do that. And now, what do you notice happens? Nothing?
Can simplify the 6 and 2.
Yeah, you can simplify the 6 and the 2. So, you can simplify here. And you can shrink it.
Miss,
Yeah.
sorry, how did you get from the second step to the third step?
Okay, hold on. I'll go over it again. Let me just shrink it. Okay, repeat. Which step?
Like the second one?
Right
Or
here?
the third one?
Oh, yes. Okay, so
One
I
of
just,
the
so here, I found a common denominator. I found a common denominator. So my common denominator is going to be 2 root x. Okay, that's what I need to be common there. And my second fraction already has it. My first one doesn't. So I have to multiply numerator and denominator by that fraction. Or sorry, by that expression. 2 root x.
And then what about the left side? What did you just do there?
The left side, I factored out an x plus root x. So when I look at this expression, see the green? Look at the green in that line. I have an x plus root x. I've got 2 of them in one part of the expression, and then I've got another just 1 in the second part of that expression. So what I do is I factor it out. And when you factor out, you're dividing. So here, 6 times x plus root x squared, if I'm dividing out one of those binomials, I'm left with only 1. And that's how I have that x plus root x. And then for the second part, I factored out the whole thing. 6 times,
Oh, I get it.
yeah.
Thank you,
And-
miss.
No problem. And that's it. And now let's go ahead and reduce. And that's fully factored. Now we are fully factored. And again, like I said to you guys, it's very common to leave it as x to the 1/2. And that's okay. All right? Are there any questions? So to
Miss,
We need someone to leave this actual one, like, on the denominator, or rewrite all these, exponents. That's the idea.
I'm not going to rewrite these. I'm going to leave them like this, and that's okay. But what you're going to notice, you're going to be dealing with a lot of binomials, trinomials that have an exponent to the 1/2. And so we just leave them. We don't go and use them. We leave them as to the exponent 1/2. This is not wrong. But if you didn't, if you left it as x to the 1/2, that's not wrong either. As long as they're positive, it's not wrong. Okay? As long as the exponents are positive, you're not going to use marks for that. Okay? Well, this is an easy one. It's just root x. So we flip it. It's fine. But if it was x plus 3 all to the exponent 3 over 2, I'm going to leave it as 3 over 2. I'm not going to change it to root 3 all squared. Or sorry, I said 3 over 2. Square root all 2. Okay? Okay, so little note here.
Miss, I had a question.
Yes, tell me.
Do you not have to rationalize the denominator at the end?
No, you don't. Not with your slopes, you don't. Because, as I said to you before, we're going to be leaving a lot of them in fraction form. And you're going to see how messy these get. These get very, very messy with derivatives, and so it's acceptable to leave them as rational exponents.
Okay, thank you.
Yeah, no problem.
So when do you rationalize
When you're taking derivatives, you don't have to rationalize. Okay, when you're taking derivatives, you do. Okay? If you have a question where it says simplify, and you have an expression, and you're left with a radical in the denominator, rationalize it. This is simplified. Now we're taking derivatives. So because we're taking a derivative, you don't have to worry about that. What you do have to worry about is that denominator. So look at this example here. Be careful to fully simplify the way I showed you in class. The textbook does not always do this. So be very careful. So for example, the textbook will leave the answer like this. This is actually pulled, I think, from one of your questions. It's going to leave it like that. That's not right. Look at that denominator. You see that? You have to bring them together. So this is now x minus x squared, all cubed, multiplied by the exact same factor, all squared. That's a common base. We add the exponent. Okay, so please guys, make a special note of this. This is not correct. That's not considered a fully simplified derivative until you bring that denominator down. And that's what I did here as well. If you feel I took that last factor, it had a denominator in it. You can't leave it like that. You must simplify it. Okay? One denominator over the entire expression. Are there any questions? Okay, so that's, yeah, tell me. No, I know what you mean. Your root. Oh, no, it's not. Oh. Yes, you got it. Yeah. But take a look at this expression, for example, the last example we did. I don't expect you guys to rationalize. Mind, you're not going to be that bad. You're only multiplying by root x. But you're going to see they get messy, especially in the quotient rule. Have you guys noticed in the quotient rule when you're doing that homework, they get quite involved, and we don't expect you. You're going to have a lot of denominators that are going to have those rational exponents, and we do not expect you to rationalize. Okay? Again, why? You got to think of why you're doing things. So the reason I'm showing you these derivatives is eventually because we're going to get to curve sketching. In chapter 5, or maybe chapter 4, I can't remember, we're going to be getting to curve sketching. And so that's where you guys are going to actually put this into practice. And so you're going to see it's not really necessary to rationalize these numbers. Okay? All righty. I think it's chapter 5. Curve sketching is chapter 5, and then our last chapter is chapter 6 for derivatives. Yes? I believe so. So, in chapter 4, that is 4 and 5. I'm getting confused. Okay, perfect. Okay. All right. Okay, guys. This is your homework, and this is your review. So you're going to notice not a lot from this section, but there is the review homework. So I have some notes here for the review. So let's write them in. So, I took it out altogether. Good. 27, I took out. 22. So for 22, omit C because it's a cusp. You guys don't have enough experience with cusps to be able to analyze them. So don't worry about 22C. You can look at it by all means and use decimals to help you. Okay, for 22C if you need, but it's a cusp, so you don't have to worry about that one. For 17A, this is the correct answer. And for F, I have a correct answer for F as well. Okay, guys, look here. So just take a look. You guys have this. I've posted all of this, so you guys have this. And you should have this. Let's confirm that you have this. You guys have this on your lesson? Okay, good. So I do them. I look at that. I mean, the first time I taught the course, right? I would do them and I would look and I would see if it was a good question or not, right? In my opinion. So, especially many years ago when I first started teaching, I was back at university, and so it was more relevant because I could see what we did in university. So what do you need? What don't you need? Some of these textbooks, like this textbook is little with these days, but there's tons of errors in this textbook, and so some of the questions are not there, and some of them are, right? You have to remember also this new curriculum that came into play. These books were written very quickly, so it was a very quick change. And that's why if you notice, and even if you're not same issue.
Like you will see, like this is a textbook. This is clearly written in terms of history. Has problems in areas.
Yeah, so you But as a teacher, right, with experience, it's my job to catch those and correct and try to miss and, you know. Yeah. I guess so. So I guess what might be important to you might not be important to somebody else, but it doesn't really work that way because you're working as a team. So there's a team of us that calculus and we always discuss. So what do you guys think about this? Do we take this out? Do we leave it? What do you think? Right? So it's not just one person making the decision. We work as a team.
It really surprised me that the homeschoolers don't have like an errata.
They do.
Well, like, or at least not publicly available.
You know what? I don't know if this textbook does, the 11U does. The 11U has an errata, just because there's so many errors. This one should. I can't say for sure if it does or not. But I just taught this course so many times that we've caught most of them. If you guys catch an error, let me know, and I'll update, right? But
We're very close to this.
errata is a list of all the errors.
Oh.
So it's basically a document where it will say all the errors and then tell you. Yeah, the 11U has that. I'm not sure if this one does.
So we're grateful for this textbook, the number of errors, and the issue with it was that the solutions were very, very close to being right without quite being right.
Oh,
So if
well,
you,
kind of like this. Like, look at the way they simplify. They almost fully simplify, and they stop. Right? Almost.
if
kind
you
of
follow
like
the 50, you get like really wrong answers. And conveniently, someone, a teacher from, well, I guess, apparently Vaughn, but seems to be renamed secondary school,
that. Cool.
posted like a list of his own errata from
Yeah,
online. That was good.
yeah, absolutely. Absolutely. So we've sort of done that as well, but not compiled it as a list. We sort of just have it in our lessons individually, right? So that you guys know. Okay, so I have an extra practice sheet that I'm going to scan and upload, okay? So it's up to you guys whether you want to do it. It's extra practice. It's not a lot. It's 1, 2, 3, 4 questions that have ABCD. So it's just extra practice. It's from a different textbook. It's from an older textbook, and so you might have a little bit just different types of questions, right? So it's good, which is good. It gives you more experience. So I'm going to scan that in and I'm going to post it. And as I said to you, you're grade 12. If you want to do it, it's up to you. It's there. I personally think you should do at least some of it, at least like peruse it and see what you want to do from it. It's extra practice. It will help you. Like I said, some of the questions are a little bit more complicated than what's in the textbook, which is what you can expect on a text, right? So good idea maybe to do the extra practice. So I will scan that. I will go and scan it right now, and I will upload it. One thing I want to resolve is the test dates. So let me just look at these test dates. I want to decide today what's going on. So let me look and let me see. How do you guys feel, you guys in class, if you don't write the next one in class, but then you write the next two in class? How do you guys feel about that? You don't care. Yeah. I'm just trying to be fair, right? So as long as you guys are writing the same number, I think, in class, I think it's okay. It doesn't necessarily have, it's too hard to do it alternating. Then these tests are getting pushed too far. So let me look at the calendar and let's see what works. Yes. Oh, T. T. Oh, I'm sorry, 3/2, yes. 3/2.